We are now on to the second model of memory. Now this is called the working memory model, and it's a little bit more complicated. There's a little bit more to it. So during this video we are just going to do the AO1 description and a little bit of exam questions, and then later on in a week we will do the evaluation too. So a little bit of a recap for you. Your starter today is, can you define the following terms? So pause the video, just quick definitions. So number one, reductionism. That is when something doesn't take into consideration all possibilities, so it oversimplifies the explanation. Determinism is when it removes all free will or control over someone's behaviour. Temporal validity is, can something be generalised across different time periods? Ecological validity is, can it be generalised to different settings? Nature is behaviour or things that are innate, so you are born with them. They're in your genetic, for example, whereas nurture believes that you're all born as a blank slate and everything is learnt or taught to you. So those are just a few key terms usually used in evaluation, just a bit of a recap that you should be a bit more familiar with. So on to the working memory model. Now the working memory model is done by Baddelley and Hitch, and I told you at the start of the memory booklet Baddelley will appear a lot throughout this booklet. But Baddelley and Hitch thought that the multi-store model is too simplistic when looking at the short-term memory. There's got to be more to it. So they mainly focused on what happens in the short-term memory and stated that there are different stores to that. The basic framework of it looks like this. So you have your central executive at the top, then you have the VISUO-SPATIal SKETCHPAD, episodic buffer, and the phonological loop. And then these all transfer to a long-term memory. So make sure your titles are in your booklet or on your notes, and then we will describe what each of those is. The little pictures in there will help you out a little bit in remembering them. So number one, the central executive is the one right at the top, and that is the one that is in control. So that is quite possibly one of the most important bits. It coordinates and controls all of the other slave systems. So all of the three underneath it, the VISUO-SPATIal SKETCHPAD, the episodic buffer and the phonological loop, it controls those. It is required to perform a number of different tasks, so it focuses and switches attention. So when you are thinking about lots of things and lots of different things pop into your head, it's the central executive that is deciding which bit to pay attention to, which bit to ignore. It does work with some problem solving strategies to try and help you out a little bit, and it connects the working memory to the long-term memory. So it's the one that's in charge, really, says where each piece of information should go, what we should be paying attention to. But it does have an extremely limited capacity and can usually only complete one thing at a time. So that is why I can't think of a lot of things all at once. Your central executive is taking one piece of information in at a time and passing that on. Then takes another, right, where am I putting that? I'll pass that on. So it is very limited. Now the next one we're going to look at is the phonological loop, and this is the sound system, or your brain's sound system. It processes everything to do with sound and is split into two parts. The phonological store, which can also be thought of as the inner ear, and the articulatory control centre, which can be thought of as the inner voice. Now we're going to make notes on each of these. They should hopefully fit into the boxes if you're writing into the booklet, but if you're not, that's absolutely fine, just make two headings. So the phonological store generally, it holds auditory memory and it traces it for a few seconds before they fade, so it has an extremely limited capacity again. It receives external sound information from the environment all around us, and it receives auditory information from our own internal speech via the articulatory control centre. So we hear in our head what we are thinking. The opposite, or the other parts of the phonological loop, is the articulatory control centre. This again has very limited capacity, got a bit of a theme going on here, but it prepares all speech and allows us to think in words, for example mental arithmetic. So in your head you say the number 2 when you see it. You don't see the outline of the number, and that is your articulatory control centre forming speech and allowing you to think properly. So it is your inner voice. What you can hear thinking in your head, this is the part of the working memory. It is determined not by capacity, but time. So it's how long it takes you to say something out loud. That's how much capacity the articulatory control centre has. So it's a little bit different in those respects. Then we've got the VISUO-SPATIAL SKETCHPAD, and it focuses on visual processing and spatial recognition. Now, its loading in 1995 that suggested that it is split into 2 separate parts. Again, not so much information with this one, only a couple of words for each one, a little bit more straightforward. So you have your visual cache, which stores visual data like colours, and then you have your inner scribe, which records the arrangement of objects in visual fields, like locations of things and movement of things. Now, these work together because when you are looking around, if you look around the room that you're sat in now, you can see everything in colour, but you also know where everything is. So you know that the table is right in front of you, you know where the chairs are, so you don't walk into them as you walk past, but you can also see it in colour, so they work together. And this has around a 3 to 4 item capacity. So that's the amount of things it can deal with at any one time. And then we've got the episodic buffer. Now, this was added fairly late on. This was added by BADDELEY in the year 2000. And he said that this was a temporary store for information that from all of the other stores. So it's something that can hold information whilst another one is busy. It allows for a bigger and more direct link to the long-term memory and wider cognitive processes like perception to be performed. And it helps to make sense of things by sequencing them, especially in time, so it does episodes. So the episodic buffer organises things into episodes. In 2012, BADDELEY did further research and found that the limited capacity of approximately 4 chunks or episodes is its capacity. And all of these pass on to the long-term memory. Now, there's a lot of research into the working memory model, and a lot of that comes under dual task performance. Now, again, BADDELEY, 1975, tested this, and he gave participants 2 visual tasks, one of which was tracking a light with their eyes, and the other describing the letter F. Then he gave them a visual task and a verbal task. So the 2 visual tasks will both be being taken up or being dealt with by the VISUO-SPATIAL SKETCHPAD. But if you give them a visual and a verbal, the phonological loop and the VISUO-SPATIAL SKETCHPAD are being used. Participants found it a lot more difficult to do the 2 visual tasks, showing that they both use the same slave system, which makes it much more difficult to do 2 of the same task. Whereas doing a visual and a verbal task was a lot easier because there's no competition between the 2 tasks as 2 separate slave systems are used. So the working memory model helps to show us why we can do some things together, why we can't do others. It is 1 slave system at a time. I can't put 2 things in there. You will be able to do it just about. So they could do tracking a light with their eyes and describing the letter F. It was just a lot more difficult and took a lot more time. And that's because there's a competition in the VISUO-SPATIAL SKETCHPAD. So when 1 slave system has 2, 3 tasks within it that are trying to be performed, that slows everything down, causes competition, causes confusion a little bit. So we don't like to have tasks performed with the same slave system. Much easier to do 2 different tasks at the same time. That leads on to the next question. So the question that is in the booklet is, it is illegal to use your phone or a sat-nav whilst driving. To be able to legally speak to someone on the phone, it must be hands-free and out of your line of sight. Use the working memory model and dual task performance to explain why one is illegal and the other is not. Now, it is 4 marks and it does say 6 minutes, but take your time a little bit with this one, just to make sure that you have gone through everything as much as you can. Now, the hint here is remember to link to the scenario all the way through your answer. So make sure you are using things like phone or sat-nav whilst driving. Think about the different stores that each uses and why one might be legal, one might be not. So pause the video, have a go answering it. Right then, so let's have a look at what type of things you should have included in your answer. So you need to think about what slave system you are using whilst driving. So whilst you are driving, you are using the VISUO-SPATIAL SKETCHPAD because you are taking in all of the surroundings, spacings, whether there's a car near you, where you need to position yourself. So it's the VISUO-SPATIAL SKETCHPAD that is being used. It is illegal to use your phone or a sat-nav whilst driving because they will also require the VISUO-SPATIAL SKETCHPAD for you to know where the letters are to type, for you to be touching and pressing in the location that you want to go to. So they both will then use the VISUO-SPATIAL SKETCHPAD, which will cause competition between the two tasks of driving and using a phone or a sat-nav, which means your ability to drive will be reduced. And that is why it's illegal and makes it dangerous, because it's a competition taking information away or attention away from driving. But it would be legal to speak to someone on a hands-free phone. And that is because on a hands-free phone, when you are speaking to someone, that will use your phonological loop. So the driving will use the VISUO-SPATIAL SKETCHPAD. Speaking on the phone will use the phonological loop, so there is no competition and therefore attention can be kept on driving, which makes it not as dangerous, and that is why that is legal. Now you do need to make sure you make constant link to what store each thing is using. So using your phone, use your VISUO-SPATIAL SKETCHPAD, driving, use VISUO-SPATIAL SKETCHPAD. Make sure you are linking back all of the time. And that is the end of the lesson, really. We've not done too much today, and the reason for that is the working memory model has a lot more to it than the multi-store model. You might feel like, oh, this is quite straightforward, we've got through it quite quickly, but I want you to go over it again and again for me, just over the next day or so. Also have a look at the online textbook and what information that gives you on the working memory model. Make sure you ask any questions, anything that you're stuck on, even leave it for a few hours, then have a think about it. Do I need to ask Amy anything? Send me an email, I'll get back to you as soon as I can on that. But can you, before the next lesson when we all do evaluation, can you make sure that you have gone over this? Remember to do more elaborative rehearsal so that you can more quickly and easily transfer it to your long-term memory so it stays there. But keep going over it because this is the more complex of the two models. So that is your little bit of homework. Hope you're all okay and doing well with the remote learning. Keep on going, guys.